Today we're going to have how to accelerate Docker adoption with a simple and powerful user experience. And Frank Davolo, a delivery manager from Société Générale, will be presenting, as well as Jérôme Baud. He's an architect at Docker. So a big DockerCon welcome for both of them.
So, hello everybody. So I am Frank Davalo. I am working at Société Générale, and I am the service manager of the Docker platform.
And thank you. Hello everyone. So I'm Jérôme Baud from Docker, and I am a technical account manager, and I work for Société Générale. Today we are going to tell you the Société Générale journey, which started quite a while ago. Frank, can you remind us when did we start the project?
It started beginning of last year.
Okay, so it's more than almost 2 years, or maybe even more, if we take into account the
there was
prototypes.
study before, yes.
So basically, you started with the very first versions of Docker, you know?
Yeah, yes, indeed.
Okay. So I let you tell us a bit more about Société Générale and the objective that you have at Société Générale.
Okay, so I don't know if you know about Société Générale. Société Générale is one of the main French banks. It's a very old company because it's more than 150 years old. So you have a picture of the headquarters near Paris on the screen. So several years ago, Société Générale decided to start a great transformation of its IT model. The goal is to be cloud ready. And so we think that we need to deliver time-to-market application for business, and we need to do a global reduction of IT cost. So we started automation, service-oriented features, and Docker. That was at the core of the transformation. So we started the Docker platform last year. So we were in production with the first application just before the DockerCon in Austin. And now we have more than 2,000 containers in a production and non-production environment.
And what is your target? What is the management objective that they ask you to reach?
So the management is expected the platform to grow 10 times. So that's what we are asked to reach. So we need to go to 15,000 containers in the coming years.
And that's the target that the management is setting in order to be satisfied with a satisfying return on investment. So can you tell us about your team and the organization at Société Générale?
Yes, so the Docker platform has been built and run by our feature team. So we are dedicated to this platform. So I am working from the IT operation department, and we are building and deploying this platform for the business units. So the main sponsor was the investment banking part. So they are deploying their application on our platform, but we are also starting to work with the retail banking and the insurance part. So the platform is based on the standard infrastructure of Société Générale, what we call the internal cloud. So we don't have a dedicated or optimized hardware for the moment. It will come, I think, next year. So we don't have use cases on the platform like high performance databases or big data. But otherwise, the goal of the platform is to be a generic platform.
Thank you. So as we previously explained, we started the project a while ago, and we went through the different phases of the hype curve. At the very beginning, the users, their internal users, they were, let's say, tech hungry, they were tech enthusiasts, and people, looking at Docker as a technology. And nowadays, I think we reach what we can call the plateau of productivity, and the users have changed. They are not the same users. They are not anymore really tech hungry. They just want something which runs smoothly, which is easy to use, and they want a very quick return on investment. And the managers, they want something that is going to grow a lot. So can you explain us what is your current strategy and your current puzzle that you have to deal with at the moment?
So indeed, we are on the first phase. I think we are at the end of the first phase. That doesn't mean that it is terminated, but we are shifting to another phase. So the first phase was a focus on performance, stability, quality of service, and security. So we had to build the foundation of the platform and to reach a certain number of users. But now, and to get some also some densification of the IaaS. But now, with the new expectation from the management, we have a new challenge, which is to attract more users. So now we need to focus more on user experience, because the new users, there is always a cost of transformation to go to containers model. So we need to convince them that they will have a real gain coming to the platform. And they are not people that are just happy to do Docker containers. They have a day to life as developers. So we need to change the focus to be able to have a good feedback from all the users and to have people coming to the platform without just transforming one application, but completely switching to the platform for all their development.
Okay, so we understand your objective, which is a huge growth and attracting new users. So today we are going to go through this agenda in order to explain the strategy and how we are going to achieve it. We'll go through some mandatory topics because it's an enterprise solution. It needs to be secure. It needs to be reliable. So we'll cover multi-tenancy and how multi-tenancy was implemented at Société Générale. We'll cover also the security and compliance checks that are mandatory topics. Otherwise, you won't be allowed to deploy an enterprise solution. And then we'll go through the different aspects that can ease the developer work, because we want to attract new users, so we want their work to be easy. So we'll go through a self-service onboarding API that we developed. We'll go through some data visualization that also was developed. And finally, we'll go through how we see what a compose file should look like, and again, for the better developer experience. First, let's take a look at the multi-tenancy. So the multi-tenancy can be actually two different strategies. On one side, you have a single cluster where everything is shared by different teams. So we call it the CaaS platform. And on the opposite side, you have the multi-cluster. So even a single cluster, but by team, if you go to the extreme. And of course, you have all the models in between. So, and it depends whether you decide to go for a CaaS or a class. It depends on your operating model. It depends on how you want to densify your infrastructure and about your organization. So can you tell us what model you decided to implement at Société Générale?
So we decided to start by a CaaS platform, because we wanted to focus on industrialization, security, and we wanted to scale also before starting to split. So in fact, we have two platforms. We have one for production and one for non-production. So we start with a CaaS platform. We know that at some point we are going to split because the platform is going to be too big. And for the retail banking, by example, we will need to have a dedicated platform. But we wanted to do all the things fine before starting to split. But the CaaS platform is important, but for the transformation and for the gain of the users, we need to provide more. So because they are used to be integrated with the company IaaS, so we need to offer them a smooth migration to the platform. So they need to find in the platform all what they are using outside of the platform currently. So that's why some of the value-added services that we had to add of the platform were mandatory. So it started by the CI/CD. So in fact, CI/CD was the first application that was hosted on the platform, because the CI/CD service offer, that is not our responsibility, is hosted on the platform. So we have something like more than 120 Jenkins masters that are running on the platform, and even the slaves and are also running on the platform. So when a team is onboarding on the platform, the first thing that they get is a Jenkins master for their CI/CD.
So Jenkins is hosted on the at the container application on the platform?
Yes, exactly. Yeah.
And how many builds a day? Can you
I think that's more like 1,000.
1,000 builds a day.
And they use Jenkins not only for Docker integration, but also for their usual deployment or build that are not linked to Docker. So that's CI/CD functionality that is migrated to Docker. So this was a big component. We had to do a lot of tuning and optimization, because they were used to use the Jenkins on their own VM, and so they wanted to have the same performance and stability. So that was a big part of our work, because in fact on the platform we are providing the plugin that links the Jenkins to the platform. So we worked a lot for the optimization of this component. And after, we worked on all the plugin volumes that we offered on the platform, so that they could find all the classic storage that they were using on the infrastructure before. So NetApp, CIFS, and so on. And now we are looking at networks plugins. So that was the first part, having a CAS platform with the good services for smooth integration on the platform.
So, if I understand correctly, you started with the CAS model, which is ambitious because you will have to deal with multi-tenancy and with security even more than in a class environment. So let's now take a look at the security aspects of this design. So first, you have to deal with RBAC. RBAC is a way to organize your different objects, like secrets, services, volumes, all the objects that are going to be created by the users. And you will have to decide what is going to be shared, maybe by a team, and what is going to be very specific. And then you will define some collections. And in Docker Enterprise Edition, you have some different collections for implementing the RBAC model. But of course, you can define your own design. And you may want, for instance, to differentiate the different applications so that one project team will not see the work of another project team. You may want also to define or to differentiate different environments. So if you are on a non-production environment, you may want to separate the QA environment to the pre-production environment or the dev environment. And you may want also to do some split or share things depending on the job role. If you are a dev person, or if you are a DevOps person, or if you are an ops person. So this is the RBAC model. So can you explain us how you decided to design yours?
Okay, so what you said is important. So when a team, we onboard not by users, but by team. So when a team is onboarded on the platform, they want to feel that they are the only one to use the platform, so they have to be isolated. So that's why the RBAC is very important for multi-tenancy. And so the first thing another thing that is important for a team is they are going to create different objects, and they have to share those objects. So we created first collections where they can share all the secrets, network, and volumes. And after, they need collections to run their services. So we provide them with collections where for each collection we have a dedicated pool of compute nodes that are not dedicated to their team, but dedicated to the collection. And after, they can choose the right collection for their services. So we have a first collection, which is for CI/CD. So as we think that CI/CD is a very specific load, because usually it's very CPU intensive. So we didn't want to merge that kind of load with the classic kind of applications that are running on the cluster.
So CI/CD are running on separate nodes. nodes.
Yes, separate collections, so separate nodes. And after we have a kind of a default collection with most of the worker nodes, where we deploy the applications that are deploying their applications. And we are starting creating more specific collections for, by example, highly secured applications, or for different specific network zones, or for specific hardware like a GPU and so on.
Okay, I understand. So, but let me think. So this configuration and this design must be quite complex to implement, no? How do you manage the configuration of such a design?
Indeed, the airbag is not complex, but you need to create many objects to implement it. And so the platform was supposed to be a complete self-service platform. So we created an API, a self-service onboarding API, where we do all the jobs using the Docker low-level API. So when a team wants to onboard to the platform, they call this API. It's a self-service, so they call it whenever they want. And after the result of the API, they are able to go to the platform and start working, creating services and so on. There is another API because we have two parts of the onboarding, which is the CI/CD and the onboarding on the platform. So this CI/CD provisioning, there is another API. It's not our responsibility, but it's part of the global onboarding.
Okay, so if I understand correctly, the airbag model provided by Docker has some low-level APIs. And on top of that, you built a higher level API so that it's a self-onboarding and everything is automated. So
yes.
Yeah. Okay. So now we covered the airbag model. Let's have a look at the hardware sharing, which is another part of the multi-tenancy. So here you see some kind of containers. And on the left-hand side, we have reservations. So when you deploy an application, you are going to reserve a certain amount of resource. And you will also ask for limits, so that when your container start to grow, this is the red part, because of some heavy load on the application. So you have, let's say, a web service which gets some request. Because the load is growing, your container is going to grow up to limit. And if you have reservation equal to limit, you will never go beyond the maximum resource of your node. So this is what I call the safe strategy. With the safe strategy, you will never have any problem, but you don't densify to the maximum. And on the right side, this is what I call the optimized strategy. You can, at first, you can put more containers on your node, but you take some risk, because if you get an application which gets more requests, your container will grow, and maybe you will go beyond the maximum resource of your node. And if it's a memory problem, a memory limit, you may go out of memory. So that's two different strategies. So can you tell us which strategy is the safe or the optimized strategy you decided to implement?
Okay, so we did not choose a strategy because the safe strategy, by example, is important for critical applications in production. But we needed also the optimized strategy because we have a target to densify the resources, the infrastructure. So we needed to have for the mainstream of applications and in non-production applications to have a policy where we try to put a lot of containers in the same host. So we needed to add some kind of safekeeping mechanisms to have an optimized strategy that is safer. So I will try to show you with this little animation that was done by Jérôme, and I thank him for all the work. So this is a little bit our daily life. So we are looking at containers that fall from the sky and on the worker nodes. So you see, it's very nice. So we see the scheduler doing his job. So the containers are falling on the right node. But as you see, at some point you are going to reach a certain level of use of the resources. So it could be CPU or RAM in one host. So at this point, as we are in the optimized strategy and there is no reservation, we have to put some kind of safekeeping mechanism. So we have a local watcher on each node that is going to watch every minute the global use of CPU and memory, and is going to put at a certain threshold, it's 80% for in our case, is going to react when we go over this threshold and to put the node in pause mode dynamically. So why do we that? We do that to preserve the node, because usually we see a spike of CPU usage that doesn't last very long. But if we do not react at this time, we know that the node is going to be unhealthy and that will impact the other containers from the same node.
So putting the node in pause, it protects the node because you don't schedule any more container on this load.
Yes.
And you just wait for the threshold to go, for the load to go beyond the threshold to authorize new scheduling on the nodes.
Yeah, because most of the time the CPU is going down after sometimes 10 minutes most of the time. And so after that, the container is, you can add more containers on it.
Okay.
But the problem is, I'm sure you see that, is when you go on, at some point you are going to have all your nodes that are going to be in pause mode or reaching a certain level of use. So we have another part of the strategy that is to have a watcher that is going to watch at the cluster level. And so at the cluster level, we are going to look at the number of nodes that are in pause or at the global use of CPU and memory, and if we reach a certain level of use, we are going to we are going to provision to do auto-scaling of the cluster and to add another node automatically.
Okay, so this is a way to enlarge your cluster on demand, to do some auto-scaling, because, yeah, you reach maximum capacity, you just have too much load on the cluster, and you need to have an extra node. So.
Yes.
Okay, thank you. So now let's have a look at at another part of the security mechanism, which is important for an enterprise solution, which is the promotion mechanism. How do you go from a non-production environment to the production environment? And how you make sure that you don't put any risky load or any risky workload on the production environment. So in Docker EE, we have several mechanisms to do some image scanning, for instance, to check if there is any vulnerabilities in the different layers of the image. We have the image signing mechanism. The image scanning is a way to check that the image was not modified and comes from a known developer. So you know what's in the image. And you also may be able to implement some specific RBAC rules, like preventing any Docker exec in the production environment. You may want to allow people to do a Docker exec in the non-production environment, but when you go to the production environment, you will likely want not to do any Docker exec. So can you explain how you did that and what is your special dev to prod process?
Okay, so security is it's a mandatory requirement in a bank. So we worked a lot with the security team to find the right level of strategy for securization of the platform. And so we decided I will simplify, in fact, to explain the strategy. It's like when you try to secure an airport, what you do is you have only several gates where you can enter the airport, and on those gates you do very strong security checks. So this is the same strategy. We want to avoid any dangerous item. So it's for the platform, it's any dangerous piece of code to enter the production platform. So the first thing is we are going to not to allow the users to push their image directly to the production registry. This will force them to pass by our dev to prod process. So this process, in fact, it's an API because we are always on the self-service strategy because we cannot have them be blocked from deploying during the weekend or during the night. So they call this API, and this API is going to check the input of this API will be the compose file, in fact. So the compose file will be parsed. We will check all the images, so checks for vulnerabilities, backdoors, or viruses. And if the images are passing all those checks, the API will send back a go, and the Jenkins process, dev-to-prod process, will push the image to the production DTR and will also deploy the stack. So this is how we do that. We are also looking at a complementary strategy, which is going to be some regular scanning of the running containers in non-production or production environment to look for the same thing, non-compliant images.
So this process, this dev-to-prod process, this is automated by Jenkins, right?
We have two parts. We have a Jenkins pipeline that they have to call manually or by API, and we have a compliant API that is called by the Jenkins process himself.
Okay, that's clear.
That's me, sorry. We talk about security. Now let's focus more on the user experience. So I don't know if you know IT Crowds. So we are the kind of the real-life incarnation of IT Crowds because we have a lot of users that are calling us every day. And so most of the time they are calling us because their application is not working, and the first thing they have in mind is a problem of the platform. So I won't say it's not sometimes a problem in the platform, but most of the times they have not checked that the status of their containers, the status of their logs, and so it's a recurrent problem for an ops team. But as we are having more and more users on the platform, and we have a big expectation to onboard more and more users, this is becoming a big problem. And if it is becoming a big problem for us, it is a problem also for the users, because this means that they have to call us because they are not able to do the first troubleshooting by themselves. So this is a problem that we are going to talk about, because we need to find a strategy to avoid to be overloaded by the user support, and to find a way to help the users to troubleshoot by themselves.
Yeah, again, the platform needs to grow 10 times, but we don't want the ops people to grow 10 times, and there is still 24 hours a day, so you cannot
exactly
do more. So. The other way around. So Docker IE provides different mechanisms to get access to data and to do some problem determination, to understand what's going on the platform. Of course, you have the Docker daemon, and you can call it by API to understand what's going on and to get some logging and data. You can also get access to the different logs of what I call the system containers, which is things like UCP controllers or UCP proxy. So you'll get logs if you do UCP controller logs or things like this. And you have also the host level information, which may be more on the useful for the ops team. And it can be used by tools like sysdig to gather some information. Those information are going to be displayed on a variety of user interface, like UCP first. You may have a data lake where you want to put all your logs and you want to do some log analysis. You may have custom scripts, of course, and you can have a console like sysdig that can provide the information. All those information have different purposes. So you can have things like important information for the developers to do the problem determination when they try to deploy a stack. But you also can have information that can do some chargeback, because it's a shared environment. There'll be different teams on the environment, and you may want to cross-charge the global cost of the infrastructure. So these are the different use cases that you may want to do with logging and data. And it can be useful for dev people or for ops people, depending on the feature. Can you tell us a bit more what you decided to do among all this to get some good information for the developers?
So indeed, we put many logs and events on the data lake for metrology and chargeback also. And what we want to do with SysDig is to provide the possibility for each team to do its own dashboarding, so to be able to create the dashboard with the data that they are interested in. So we are working on that. But we are also working on training, because training is something important, and on documentation. But what we still lack is what we see is we have the user, what I was talking about before, is they have the possibility to do the troubleshooting by themselves actually when going to UCP or going to all the logs that are available. But they don't do it. So we need to provide them with something that is simpler than all those items. So what we are doing is we are trying to prototype what we call a dev console. So the purpose is to have in one screen all the information that is needed by the developer. So some people say the developer is lazy. I won't say that, but we need to have something that is already ready for them for simple use. So it's very simple information. In fact, we have a filter with the airbag, so the developer will see only what he is supposed to see, and he will see the status of the containers, the error message when a container is looping in error, which is the most common problem that we have, and he will be able to have a live streaming of its logs while clicking on the container, or to have a quick inspect of the service of the container. So what we try to do, and we will test it with the developer, is to provide a simple tool for them, so that they are eager to do the troubleshooting by themselves before calling us.
And everything on one console instead of having to go to UCP and doing some Docker service inspect or things like this. Okay, now let's have a look at the compose file, which is the tool for developers to deploy their stack. The compose file, we discussed that this week. It's actually a configuration file that can evolve on the pipeline towards to prod. So you'll have likely a very small compose file at the beginning with only application-related information. But when you go to the test environment, you will maybe add some integration parameters. And when you go to production, you will probably add some infrastructure parameters, just like limits, as we said before, or I don't know, airbag labels or things like this, which are not application-related, actually. So can you tell us what's your vision on the compose file and how it should look like?
Yes, so the compose file is a very important part, because it's the main input that the developer is going to have to provide to build on the platform, to deploy on the platform. And as we have more and more users that want to use the platform as a commodity, we know that they are not going to be experts on compose file. So we want them, in fact, to focus on what is their main concern on the platform. So only the information that are their main focus. But in the same time, we are asking them to add airbag information. We are asking them to add some specific policy like restart and so on. So we are asking them to add more and more technical information. So we are not going to the right way, because we are complexifying the compose file. And the problem also is that those things that we are asking them to add are going to evolve with time. So we are going to go to the 100 or several hundred developers every, I don't know, 3 months or so, and ask them to change a little modification for the airbag or so on. So this is a very important thing for us, because we think if the compose file is too complex to maintain, it's going to be a problem for the platform.
And it's going to increase the workload that you'll have to support completely. And to do.
So what we want is to split the compose file in 2 parts. One is the one that the usual developer developer is going to be very keen to implement and to provide, and another part that is going to be perhaps at the responsibility of the team or at the department or even at the platform, and they are going to evolve on a different life cycle. And what is interesting, so we discussed yesterday with people from Docker, and they are working on making evolution to the Docker stack command line to be able to have two compose files on the same Docker stack deploy, and they are going to add some kind of a merging operation. That's exactly what we want to do, to be able to merge two kind of compose files with the technical one that will be a little bit more like templating, and to have at the end a merged compose file. So I think we are on the same direction, and that's good because that's what we want to do.
Okay, so thank you, Frank. So we understand that because we are scaling, because this is an enterprise solution, there is lots of constraints. But you don't want those constraints to be on the shoulders of the developers. You don't want them to bear all the pain and to have to get something which is not part of their responsibility. So you want something which is simple, so that users, they still are happy to work with Docker, and they continue to adopt the platform. So we've been following this strategy for a few months now. So can you tell us about the first result that you noticed?
Okay, so indeed, the first focus was performance stability. So that's mandatory on a platform like that. So, and we saw that with the stability and performance that was getting better, we were able to do more densification of the IT. So the two goals were getting better. So this was the first thing. The second thing was security. So we did a lot of discussion with security teams, and all the remediation that we discussed with them are now ready, and we will have some kind of audit next month where we will have some penetration test and audit, and we hope to get some internal certification from the security guys. We know that on those both items we will need to have more evolution, and it will not be the end of the story, but the first foundation are here, and we think we have reached a first level of the target. Now, indeed, our focus is more about users. So at the beginning of the platform, we were adding users like something by batch. Every month, we are accepting a certain number of users because we knew that we were on a building or learning phase. We don't want to go too fast, to go step by step, and so this was a kind of protective way to increase the platform. But now the decision from the management was to open the platform, so there is no limit on the onboarding of the users. So they call the API and they come to the platform without our notice, in fact. So we are in a different phase. It's going fast, and so all the problems are going fast also. So we have to maintain the scalability of the security, the stability, and also the user acceptance. So the fixback is very important. So if the platform is having some troubles, or if it's difficult for the users to use the platform, we will have bad feedbacks, and it will slow down the flow of new users. So we will not be able to reach our target. So it's a very different kind of issue that we have to solve now.
Okay, so thank you. That's very good results. I think you are indeed growing fast. So can you just tell us a bit more about the outlook in the next term? So what do you want to improve? Or?
Yes, sure. So we are integrating Kubernetes because we have users that want to use Kubernetes. So we will add collections where we will have dedicated Kubernetes nodes. So at the moment we are only using Swarm, but in few months there will be able to choose between Kube collections or Swarm collection. So this is something we are working on. So we are still working on the compose file. We are looking at the different possibilities, and we will see when the Docker implementation is done, and if it fits completely what we want to achieve. And we also are still working on the data visualization tool to have an easy tool for the developer.
Okay. Any takeaway for us based on your experience?
So I think you already talked about that. A platform is many rules and constraints, and so we have to make them transparent. And we cannot bear all the constraints of security, multi-tenancy on the users. So that's the complexity of the target is to have a simple platform, easy to use by the developer, and also to have mandatory constraints that are applied because it's a complex platform also.
Thank you very much, and thank you everyone for staying so late. So.
Nice.
If there is any question, feel free. Otherwise, we'll be at the party tonight, so there'll be plenty of time.
I don't know if there is a microphone for.
Yeah, we can discuss between you and me. That's we are not far away, so that should be.
My team's been struggling with the chargeback part.
Yeah.
So if you're doing a multi-tenancy deployment with lots of teams deploying their stacks, our approach has been using labels with monitoring to look at metrics and trend data. But I was just curious what your approach has been.
So the question was about chargeback, how we decided to implement the chargeback, and what was the approach chosen by Société Générale regarding chargeback.
At the moment, we are, in fact, on each node, we are streaming the Docker stat, and we are putting that on the data lake. And so all the metrics are at the container level. And we have another topic on the data lake where we put the mapping between a container and an organization. So after there is a specific feature team that does the chargeback, that is going to do the account for one organization and to build them.
Yeah, we've been using tables where we put the specific charge codes.
Okay.
So that's been helpful.
Yep.
As your production cluster grows, do you think you're going to be able to stick with the CAS model, or do you think you'll need to break up into clusters?
Yes, I think at some point we are going to break the cluster. I'm not sure we reached this point, actually. We are something like, it's in a dev environment, we have 30 nodes. But we are trying to be aware at the right moment to do the split.
So is it being driven more by the physical constraints of the cluster, or just by the complexity of having a lot of teams?
What will be the decisive point to split? That's it?
Maybe I can answer that.
The scalability is going to be something important. So we are looking at if the cluster is good, and when we add more nodes. So I think that's one important thing, but I don't know if you have another idea.
I think it's also a matter of organization. So if you have a line of business which is on a very specific network zone, there is no way to do something else than just deploying a single cluster for them. So it's kind of network constraint and probably also operating model. They just want to not share the workloads with another line of business. So, because almost two different companies. So.
Thank you.
Thank you. Yes, question?
So another question regarding scalability is that as your cluster grows, do you find that, because I saw that your storage is called main cluster, the compute cluster and the storage cluster are separate. Do you find that the storage will become a bottleneck, or is the storage not a concern?
So maybe I repeat the question, I'll let you answer. So the question is about storage and whether the storage, because it's outside of the cluster, whether it could be a bottleneck for the cluster.
In fact, we don't have so much use of the storage for the moment because databases are not on our model. We have a specific hardware dedicated and so on. Perhaps we will have that scheduled by Docker at some point, but for the moment we have a dedicated hardware. So as we do not use big data or databases, the need for storage is not so high. We have some applications that are using it. So Jenkins, by example, we have the Jenkins mastered. All the configuration is on a NetApp storage, but it's not something that is very critical to the cluster. And for the moment, it's not something that we are worried on for the scalability.
As time goes forward, do you think that you will migrate the databases into the single cloud?
That's a good question. I think we are looking next year at having a more dedicated and optimized hardware. And so at some point, yes, at the moment they are looking to add their APIs on our platform. But adding all the hardware will go after, I think, because they are also looking. We are a new platform. 1 year is not a lot, so a lot of people are looking and are thinking what is the right moment to go to the platform. So the databases, and they started just at the same moment as us to create a new environment. So it's difficult for them to change that now.
I had a question earlier about, to clarify what you talked about earlier about the compose file. You were saying that as you go from development to production, you were thinking that you would have to split the compose file into 2. Is that it? Or?
Yes, we think that the cluster, we will have to create a new cluster at some point. We think there is we don't know when we will have too much containers or too many nodes on the same cluster, and we will have some performance problems. There is an unknown point where when we are going to reach that point. So we are waiting for this some sign that shows that we are reaching some scalability endpoint.
But so far we have, let's put some numbers. So we have there's a cluster, as we said, that is running more than 2,000 containers at any moment in time. We want to grow 10 times. There is a densification of 60 containers per node, roughly. But we keep on growing. Every month there is 200 new containers on the platform. So there is a 10% or 20% improvement, 10 to 15% improvement every month.
Yeah, we cannot calculate what is the point of where we have to split. So we are looking each month and trying to find the right key points.
It's not at that point yet, right?
Sorry?
Not at that point when you need to split it yet, right?
Sorry?
Not at the point where you have to split it yet.
Yeah.
Like, right?
So the pausing is automated. It's every minute. And for the auto-scaling, we are in the process of automated it. It's more a problem of the provisioning of a new virtual machine and all the installation. It's kind of complex to do a nice automation. But the automation of the threshold for the cluster, we have almost finished it. But the pause mode, yes, it's automated already. And it's used every day. So every day we have nodes that are in pause. So it's not something that is happening every week. It's happening every day.
Is your intention to actually have the cluster be such that it stays close to your engineer's limits? Do you keep just a little bit of a buffer? And is that for purposes of return on investment or
Yes, we are trying to densify because we see that most of the time we have if you look at the chargeback, for example, we see that the global CPU usage is very low. Even if we have something like 60, 80 containers by node, even with that, the global CPU usage is not very big. So we have CPU spikes, but the global usage is very low. Memory is more complex, but even for memory, we have difficulties to reach. Our problem is to deal with the spikes of memory, CPU, and things like that. But and we don't want to go too far on the densification also, because we know that we need to keep some margin. Because if we lose 1, 2, or 3 VM, it will take time, even if it's minutes, to find to reprovision some new host. And so, when you have 200 containers to be rescheduled, it can be a big impact. So, we are still working on the right strategy for that. But we want to automate everything, so that at least we can after tune the parameters and have everything that is dynamic.
Okay, let's go to the party.
Okay, thank you very much.
Thank you.